I'd like to take this opportunity and greet you, grade 11s and grade 12s, as well as the people that are upgrading their physical sciences results or marks. So I'll take you guys to, actually I'll be showing you how to answer these questions. If you haven't watched my lessons on Newton's laws, make sure that you go and you pause this video, then you go, then watch those lessons so that you can understand how we use those notes to answer questions. So before I continue with the video, thank you guys for subscribing. Thank you for sharing to other people. Please do not forget to like and comment. I'd appreciate that, guys. Even if you can write, we thank you, Maths and Science series, or we thank you, Brother Elton. I would appreciate that. Okay, now let's do question 4. I hope that you guys watched this lesson. It's not a lesson, actually, a way. Actually, it's a video that I was answering these questions. So please make sure, guys, that you watch it. Also, it's very, very important. It's very important. So make sure that you do what you like the video. Thanks. Okay, question 4. A worker at a construction site pulls two blocks A and B of masses 16 kg and 24 kg respectively across a rough horizontal surface. When you talk about a rough horizontal surface, they are telling us that there is frictional force, but they didn't specify which type of frictional force are they referring to. We have two types of frictional forces, which is kinetic frictional force and the static frictional force. But let's continue to read the statement, then we'll find out. Okay, a worker at a construction site pulls two blocks A and B of mass 16 kg and 24 kg respectively across a rough horizontal surface using a light inextensible rope Y. Now, inclined at 64 degrees to the horizontal, the 16 kg and the 24 kg blocks experience frictional forces of 3.5 Newton and 4 Newton respectively. So this statement actually represents what is happening between these two blocks, block A and B, or block 16 kg and block 24 kg. So the worker exerts a constant force of 120 Newton on the block B. The blocks are joined by a light inextensible bar X. The masses of rope Y and bar X are negligible, meaning that you can neglect them compared with those of blocks A and B. 4.1.1, they want us to define the normal force. When you define normal force, you say that a force exerted by an object with which it is in contact and which is perpendicular to the surface. So I won't write it. Make sure that you pause the video. So 4.1.1, when we define normal force, we're saying that a force exerted by a surface with which it is in contact and which is perpendicular to the surface. All right. Now, let's continue. 4.1.2, they want us to define frictional force is a force that opposes the motion of an object and which acts parallel to the surface. If you can go to that lesson of Newton's second law here in our YouTube channel, you can find there where we were discussing or explaining these types of forces. And because it's very important for you to understand what frictional force says, like understanding, not only to just know how to define it, but to have the understanding of what is said by frictional force. So 4.1.3, draw a labeled free body diagram showing all the forces acting on the 24 kg block. Since it is 5 marks, they are indicating that you must show 5 forces that are exerted on the 24 kg block. 4.1.3, we can see that the block is in contact with the surface. The normal force exists. You can go to that lesson so that you can find out why we say normal force exists here. Then Fg. Then this force here, this is force applied. You can show it as it is, or as it is drawn, which is F applied. Don't show the angle or the angle 64. Then what else? The tension of block 24, it is on the left, then of 16 kg is on the right, which is Ft. Now we have 4 forces then they said 5 marks. Since we have 4 forces, it means that we have Fk. Why? Because they said something about the type of a surface we are having. We are having a rough surface, right? Therefore, it's F, right? But let's find out what type of frictional force are we having. So here, 4.1.5, if we can check 4.1.5, the last one on your screen, coefficient of kinetic friction, meaning that the frictional force that they are dealing with, or the frictional force that is present here in this scenario, it's Fk. But if they talked about kinetic frictional force or static frictional force or coefficient of static frictional force, we would write Fs, but now we'll write Fk. I don't know if you understand it. Now you have that 5 marks. 4.1.4. This is my favorite. They want us to calculate the normal force of block B. This is what you must know. If you have a scenario like this, like block A, this is the formula to use for you to calculate the value of the normal force. And this formula, you are not using it for all the scenarios here in Newton's second law for calculating what? Normal force. But if you have this type where Fa is pulled, this is the formula you must use. Fn equals Fg minus Fa perpendicular, which is mg. Remember, Fg stands for mg, or it's equivalent to mg. Fa sine theta. Do not put cos yet. Sine theta, it is cos if this is Fg perpendicular. Then if you have your object in an incline or on an incline surface, then it's Fn equals Fg perpendicular, which is mg cos of theta. But now the formula that we're going to use is the second one. Why? Because the object is in this form. So this is the formula that we are to use, which is Fn equals mg sine theta. But you can write this before writing what I wrote there. Okay. M is the mass, 24, right? Because they want us to calculate normal force on block B. 24, 9.8. Sorry, here it's Fg minus mg sine theta. What did I write here? Okay, sorry guys. 4.1.4, it's Fn equals Fg minus Fa perpendicular. Then when I simplify it, becomes mg minus Fa sine of theta. M is 24, then G is 9.8 minus the value of Fa, which is 120. 120 sine of theta. Theta is 64. Then you can punch everything in your calculators. Then 24 times 9.8 minus 120 sine of 64. Then you'll have your answer, or the value of Fn as 127.34 Newton. So this is the answer. This is the answer. So it's very important for you to understand that you don't use this formula all the time for you to calculate the value of normal force, but you check the type of a scenario. But if they ask us to calculate the normal force of block A, we would use that formula. I don't know if you understand that. Therefore, 4.1.5. 4.1.5. Okay, 4.1.5. Calculate the coefficient of kinetic frictional force on block B. They want us to calculate the coefficient of friction on block B. So the formula that we can use, or we must use, is this formula, which is Fk mu k normal force, or times normal force. Okay, let's check if we have the value of Fk. The value of Fk, okay. A worker at the construction site pulls 2 blocks A and B of masses 16 kg and 24 kg respectively across a rough horizontal surface. using a light inextensible rope Y inclined at 64 degrees to the horizontal. The 16 kg and the 24 kg blocks experience frictional forces. So the first one is of block A or 16 kg. Then the second one is of block 4. Not block 24, meaning that this kinetic frictional force here belongs to the 24 kg block. Then you will write the value of Fk equals mu kn multiply or mu k multiplied by n, not mu kn. Okay, the value of Fk, we don't use the direction of the normal, the direction of on the free body diagram, but we take it as positive because we cannot have the negative mu k. So it becomes 0, is it 0.35? No, it's the 4. 4 equals mu k. What's the value of mu k? The value of mu k, they want us to calculate the value of mu k. We don't have it. Now, what's the value of normal force? You have to calculate it. The value of the normal force on block B. So this is the value of the normal force. I don't know if you guys see that. That's the value of the normal force, which is 127.34. That's the value of the normal force. Therefore, you can divide both sides by 127.34. 127.34. Therefore, 4 divided by 127.34 becomes 0.03 equals mu k. Remember, it doesn't have SI units. Why? Because it is the ratio of two forces. If they ask you why is mu k or mu s not having or if they ask why is coefficient of kinetic friction or coefficient of static friction not having SI units, it's because it is the ratio of two forces. So yes guys, let's continue with our lesson. Let's continue to do not a lesson actually, here we are answering questions. Let's do the second one. Guys. I hope you understood this, but this is very, very, very important. Make sure that you understand this, you practice it until you know it, and do not forget to like, please. If you understood this question 4, just you can comment saying whatever that you want to say. We'll appreciate that. Let's continue.